All right, let's get started. So today, I'd like to talk about our third exam. And so there's no homework due today, so you can just kind of get started studying for the exam. And so let's talk about what will be on it. So basically, this exam is just covering everything that we've covered in chapter 4. But let me go through some things. So the first thing that we talked about is finding absolute maximum and minimum. So finding absolute maximum and minimum. So that's, again, where do absolute max and mins happen? Well, they either happen at critical values, right, or they happen at endpoints. So to find absolute max and min, find all the critical values and then test them in the endpoints in the original function. Okay, so here's one that's a little different. This is something that I do every year, and that is on the mean value theorem. So there were 4 big theorems that got proved in the lectures. There was Rolle's theorem, mean value theorem, constant difference theorem, zero derivative theorem. And of those 4 proofs that I did in that lecture, one of those will be on the exam. Okay, and I'll actually ask you to prove that theorem. So you need to know those 4 theorems and how to prove them for the exam. And one of them will be on. So let me write this down. You need to prove Rolle's theorem, the mean value theorem, the zero derivative theorem, or the constant difference theorem. Okay, so one of those 4 will be on the exam. Okay, and then we started talking about all the things that we can learn from derivatives using the first and second derivative. So I'll start just writing these down. We need to be able to find where a function is increasing or decreasing. We need to find where it has a local max or min. And that can be using the first or the second derivative test. We need to be able to find where a function is concave up or concave down. And we need to be able to find where a function has inflection points. Okay. So those are all the pieces of information that we can get out of the first and second derivative for a function. Then we should be able to use all of that information together to sketch a graph of the function. So we should be able to sketch a graph of the function. Then we did optimization problems. And then finally, we talked about L'Hopital's rule. So that's everything that we've studied in chapter 4. So I think that what I can pretty much guarantee is that every one of these things will be on the exam. So there will be a problem where you have to find the absolute max and min. I'll ask you one of these 4 theorems to prove. Then there's going to be a problem where I ask you to find for a certain function, where is it increasing and decreasing, where are its local max and mins, where's it concave up, concave down, find the inflection points, and then sketch the graph, all in one problem. Okay, so all of this stuff will be on, including this guy. There will be one optimization problem on the exam, and then there'll definitely be at least one L'Hopital's rule problem, possibly more than one. Okay, so all that together, like everything on this list will definitely show up on the exam. The good news is, like this problem, where you have to prove one of these 4 theorems, if you just learn the 4 theorems, you're good to go. And when I am even teaching my upper division students and they have proofs on their exams, what I tell them is there's always 2 ways. If I tell you you have to know a proof for an exam, there's 2 ways to learn it. One is not the way I recommend, but it does work, and that is just straight up memorize the proof. That's not the way that's the easiest, but it does work. So you could just like straight up memorize these 4 theorems and how you prove them, and you're good to go. The other way you could go that I advise is actually understand them. It's much easier to reproduce a proof that you know what it's talking about than one that you're just kind of like writing the symbols down that I should write down. That's usually when you make a mistake. So understanding the theorem first and then learning how to do it yourself, that's a good way to go. So I think, and this is it. This is all that will be on the exam. So in some sense, I kind of feel like I just told you what the exam is. Like there's no secrets at all here. If you know how to do all these things, it will probably go pretty well. Now, I think probably the hardest part of this exam is the optimization problem. Just optimization problems are a little more tricky, and so practice doing some optimization problems. Make sure you feel comfortable, especially with the ones that were on the homework assignment, and you should be prepared. A reminder about Math Lab, if it would be helpful to anybody, that it's meeting still over in Lemons 15, Sunday through Thursday nights. So there's still opportunity to go in and get some kind of tutoring help if that would be worthwhile to you. So any questions? Yes.
On the proof, are you going to say that use Willis theorem to prove whatever, or are you going to just figure it out?
Yeah, all that I'll say for this problem is I'll say something like, prove the zero derivative theorem. That will be the whole problem. And so then you will have, oh, that's not true. Okay. I'll also write out what the zero derivative theorem is. So I'll write the theorem, and then you need to give the proof that I gave in the lectures online. The proofs are also in the book. So if you use the book's version, that's fine. Well, yeah, if you use a book version, that's fine. If you use the one that I did online, that's fine. I would go with the one I did online. So just watch those lectures, take notes over my proof, and then reproduce that proof on the exam. Any questions other than that?
That's on the lecture, the 4 theorems.
Yes. Yeah, these 4 should be on the lecture over the mean value theorem. Yep. Any other questions? Okay, so let's review for the exam. Groups A and C take their exam on Wednesday, and then Group B takes their exam on Friday. And so I will either see you on Wednesday or see you on Friday. If you have any questions in between now and then, I have office hours today from 11 to 12, and so feel free to come see me then. Tomorrow I have some office hours in the morning, but I do have an appointment tomorrow morning, but I'll be around most of the day tomorrow. So if you have questions tomorrow, just stop by my office and you should be able to get me. If you don't or can't come see me, go to Math Lab to get some help in the next couple of nights, or find a friend or something. So I think that's pretty good. I know it's kind of a short little time together, but I think you're ready to get studying. So unless there are any other questions. All right, anybody online, any questions? All right, well, thank you everybody, and I will see you either Wednesday or Friday. By the way, I will mention one other thing, and that is there is an assignment that is assigned this week that will be due on Monday. So after the exam, whether you take it on Wednesday or Friday, there is a homework assignment that will be due on Monday. Okay, and that's posted online over antiderivatives. Okay? All right, have a good day. Hello.
Hello.
Let me shut this off real quick.